Imagine the early universe. It was a hot, dense soup of particles. Then the universe expanded and cooled. Gravity began to sculpt the universe. Huge clouds of hydrogen and helium collapsed. These clouds ignited, becoming the first stars. These early stars were giants. They lived fast and died young. Their deaths enriched the universe. The explosions scattered heavy elements, the building blocks of planets and life. From the remnants of these explosions, new generations of stars formed. As stars clustered together, galaxies were born. These vast cosmic islands became the nurseries for more stars and planets. The universe was evolving. It was becoming a place where life, at least in principle, could emerge. Our planet, Earth, formed about 4.5 billion years ago. Life arose here remarkably quickly. The first single-celled organisms appeared about 3.8 billion years ago. But could life have arisen even earlier in the universe's history? We know life requires certain conditions. Could these conditions have existed before Earth formed? Could life have preceded our own planet? This is a question that fascinates astronomers and astrobiologists alike. The universe is vast, it's ancient. Our planet, in the grand scheme, is relatively young. This begs the question, was Earth the first cradle of life, or were there others, perhaps billions of years earlier? The answer may lie in understanding the conditions necessary for life's emergence. Life, as we know it, needs a few key ingredients. Liquid water is crucial, acting as a solvent for biochemical reactions. Organic molecules, the building blocks of life, are also essential. Finally, life needs a stable environment to flourish. The early universe lacked these ingredients. It took time, hundreds of millions of years, for stars to forge the elements necessary for life. Carbon, oxygen, nitrogen. These elements were not present in the universe's first moments. They had to be created through nuclear fusion in the hearts of stars. These elements were then scattered into space by stellar winds and supernova explosions. From this enriched material, new stars and planetary systems formed, eventually giving rise to environments where life could potentially take hold. But the question remains, how soon after the Big Bang could these conditions have existed? Section 4. The habitable epoch, a universe primed for life. Some scientists propose a fascinating concept, the habitable epoch. This epoch represents a period in the universe's history when conditions might have been particularly conducive to life's formation. This era, roughly 10 to 17 million years after the Big Bang, saw the emergence of the first stars and galaxies. During this epoch, the universe was rich with hydrogen and helium, the fuel for stars. Supernovae were common, seeding the cosmos with heavy elements. This period could have been a time of intense star and planet formation. While the evidence is still circumstantial, the possibility of an early habitable epoch is tantalizing. Section 5. Ancient life, distant echoes. The search continues. The search for life beyond Earth is one of the most profound endeavors in science. We scan the cosmos for planets orbiting distant stars, seeking worlds that might harbor life. We look for signs of water, oxygen, or other biosignatures that could hint at the presence of living organisms. Finding evidence of ancient life, especially life that predates our own, would be a revolutionary discovery. It would reshape our understanding of our place in the cosmos. It would suggest that life is not a fluke, but rather a fundamental consequence of the universe's evolution. The quest to find signs of early life is a daunting challenge. The evidence, if it exists, will be faint, perhaps buried deep in the cosmic record. But the search continues, driven by our insatiable curiosity and our desire to know whether we are alone in the universe. The possibility of a universe teeming with life, perhaps even civilizations that predate our own, is a powerful motivator. The search for answers goes on,